talk about a right triangle first. Okay, the side in a right triangle that's opposite the 90. Okay, opposite the 90. That's always called the hypotenuse. No. That leg, or I'm sorry, that side is called the hypotenuse. It's opposite the 90. And it's always the longest. The other two sides are called legs. There and there. The theorem is on page 275, and it's a little bit long to write out for what they're saying. So I would abbreviate it. 275. You got that? Okay. The hypotenuse leg theorem, I'm going to call it the HL theorem. It says that if the hypotenuse and leg of one right triangle, if the hypotenuse and leg of one right triangle is or are congruent to the hypotenuse and leg of another right triangle. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Good. The triangles are congruent.
So HLT Hamlet's.
Could be. Could be. And a picture would look something like right triangle and another right triangle. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay? Nicely done. Great minds think alike. So this picture here, are they congruent by hypotenuse leg? No, because you don't know anything about this hypotenuse, do you? Okay? These would not be congruent by hypotenuse leg, or there's not enough information. What about now? Hypotenuse and leg of one congruent to hypotenuse and leg of another.
But if that other one is congruent on the triangle,
If that one's not,
Oh wait, that already makes it.
yeah, we haven't talked about it yet, but that one doesn't have a chance. It's got to be. If two sides and one angle of a triangle are congruent to two sides and an angle of another, then the third side is going to be congruent. Clear? Okay, now this is difficult, so focus and pay attention. Yeah, sorry. You got a right triangle, and its sides are x and x plus 3. You got another triangle, and its sides are 3y and y plus 1. Two right triangles. The question is, what are the values of x and y so the triangles congruent by hypotenuse leg? Alright? So what do x and y have to be equal to for the triangles to be congruent by the hypotenuse leg theorem? Here's how you would set this up. What does the x plus 3 have to be equal to?
3y.
Right, so x plus 3 has to be equal to 3y. Hypotenuse congruent to hypotenuse. What does x have to be equal to? Y plus 1, right? Hypotenuse leg congruent to hypotenuse leg. So now you've got two equations, don't you? Both of these equations have too many letters in them, don't they? If you solve for x here, you're going to still have a y in the equation. Well, x is already solved for here, and it's got a y in the equation. You got to get a value for x and y.
So you put y plus 1 plus 3 equals 3y.
Very good. What you do now is you substitute. Okay, you do what's called the substitution method. You know that x is equal to y plus 1. So you rewrite the top equation by substituting. Okay? So where there's an x in the top equation, what can you put there? You can put a y plus 1. So you're going to get y plus 1 plus 3 equals 3y. Then you can combine like terms, and you get y plus 4 equals 3y. If you substituted, you knew that you were told that x was equal to y plus 1. So in the top equation where there's an x, you don't have to write the letter x, you can write y plus 1 because that's what it's equal to. Subtract, nope, you don't subtract 4, you subtract y from each side. If you subtract y from each side, then 4 equals 2y. You divide by 2, and 2 equals y.
If it's 2 equals y, then that means x equals 3.
Good. Now that you have a value for y, you can take it and you can substitute it right here. So x is going to be equal to 2 plus 1. So x equals 3. And those are your values for x and y that would make those triangles congruent by hypotenuse leg. Okay? We're doing a little bit of that today. You're doing a little bit of review from the last section. Any questions? There's your assignment for today.